Hello and welcome. In this video, we will see another simplification form, that is Gribach normal form. And along with that, we will also discuss how to remove left recursion. In previous few videos, we have seen how to convert context-free grammar into Chomsky normal form. And we already know that Chomsky normal form is having production either A gives BC or A gives A. That means on right hand side of any production, there should be two non-terminal or one terminal. Context-free grammar is said to be in GNF, that is in Gribach normal form, if all the productions are of the form A derives small a alpha. That means the right hand side of any production must start with some terminal symbol. Alpha is any string of length 0, 1 or any number of variables. Then it is called GNF form. For GNF form, sometimes we may need to remove left recursion from the grammar. Let us understand what left recursion is first. So if our production is of the form A derives A alpha, then it is called left recursive grammar. Here on left hand side of the production we have capital A and right hand side is also starting with capital A. So if both these symbols are identical, then it is called left recursive grammar. To eliminate this, for example, this is the grammar A derives A alpha oblique beta. So we have at least one production which is having starting symbol on left hand side and right hand side are identical. So this is left recursive grammar. To eliminate the left recursion, we have to do this. Whichever productions are not in left recursive form, that is beta, we have to attach one more symbol to beta, that is A dash. And with that A dash, we have to add the production removing that left recursive symbol, capital A. So capital A alpha will become alpha A dash. So here now we are removing the first capital A, and after that entire production of alpha, we are attaching that A dash, the symbol we have assumed. And we also have to add one more production, that is A dash derives epsilon. I repeat, to convert the given left recursive grammar into non-left recursive form, first we have to add the production A derives beta A dash. So if we have multiple such left recursive productions, then all we have to add, and we have to attach A dash at the end or some symbol, maybe B or C or X, Y, Z, whatever you wish. But that symbol we have to add, and starting from that symbol, we have to add multiple productions. The first one will be, we have to remove capital A and whatever is the remaining part, that part, and then we have to attach A dash with that. If we have multiple left recursive productions, then for all productions we have to repeat it. And finally, we have to add A dash derives epsilon. Let us try to understand it with the help of example. Consider the grammar. This is the left recursive grammar because in the second production, L derives L, S. On both the side, we have capital L. First production is not left recursive, so we will copy it as it is. In second production, we have two production actually. L derives L, capital S and capital S. Second production of L is not left recursive, so we will copy that and we will add some symbol L dash at the end. That is L derives S L dash. We have to add the production starting with L dash now. And we have to add in such a way so that left recursion should be eliminated. So wherever there is a capital S, wherever there is capital L, that we have to remove in the production of L. So L derives L, S will become S. And after that we have to add L dash. And one more epsilon production of L dash we have to add. So ultimately these three productions will considered as a non-left recursive productions. Now we do not have any left recursion in this grammar. Let us take one more example. A derives AC, A derives ACD, A derives BD and A derives epsilon. First two productions are left recursive, last two are not. So last two we have to copy as it is and we have to add some symbol A dash at the end. So A derives BD will become A derives BD A dash and A derives epsilon will become A derives A dash. Because when you concate A dash with epsilon, it will become epsilon dot A dash. But whenever you concate anything with epsilon, it will be just the thing or the symbol which you have concatenated with that. So we are left with just A dash. Next, we have two productions which are of the form left recursion. So we have to start production starting with A dash, that is A dash derives. Now we have to remove that capital A, and capital A dash we have to attach after the production. So capital AC will become CA dash and capital ACD will become CDA dash. And finally we have to add A dash derives epsilon. And to convert any grammar into GNF, we have to follow these steps. First, we need to simplify the grammar. This is the common step in CNF and GNF conversion. And to simplify the grammar, we have to eliminate the null production, we have to remove the unit production, and we have to remove the useless symbols. I have already uploaded individual videos for all these three. So if you have any confusion in doing this, please refer all my three videos. Second step, we have to remove all the variables with A1, A2, A3 up to AN. Remember that we have to rename variables only, not the terminal. Variables indicates non-terminal, capital letters. If there are small letters, we have to keep them as it is. And then we have to apply this condition that for every production of the form, EI derives AJ alpha, where alpha is some string of terminal and non-terminal with I greater than J. So in this production, we have to check whether I is greater than J or not. If it is so, then we have to modify that production to make it I less than or equal to J. And after that, we have to remove all the left recursion. And once left recursion is done, we have to get everything in GNF form. We know that in GNF form, all productions are starting with terminal. So on left hand side, we have non-terminal, implies some terminal and some string of combination of alpha and some combination of terminals and non-terminal. So the productions will be always in form of A derives small a alpha. These are the steps for converting context-free grammar into GNF. In next videos, I will discuss few examples of converting CNF into GNF. So stay tuned and watch next videos. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.